correlational designs, associations, and multiple variables analysis. This presentation is also called simple. Moving on to complex designs. By the end of this session, you should be able to understand the fundamental differences between experimental and non-experimental research, define specific research designs that belong to the experimental and non-experimental genre, perform simple tests of hypothesis, achieve more complex tests of hypothesis, interpret results from simple to complex designs, and write up results of tests of hypothesis in APA format. This is a slide that you should have already seen in the previous session when we talked about various types of research designs in quantitative research. To recap, when we take a look at quantitative research designs, we could actually divide them into two sort of worlds. One is non-experimental study above here. This is the line that demarcates this approach. And you have experimental studies right here below. To determine whether the quantitative research is experimental or non-experimental, you start by looking at the independent variable. If the independent variable can be manipulated, if your answer to that is yes, then it moves towards the world of experimental studies, right? And I've given examples of how this can be thought about. So how does information communication technology innovation affect student achievement? Obviously here, student achievement is the dependent variable, the effect, and the cause is ICT innovation. If the independent variable, ICT innovation, can be manipulated, it's an experimental study, and it usually involves the intervention of the researcher. So experimental studies look at intervention. There has to be an intervention. So that could be clearly stated by looking at that first question and making it more specific. What is the impact of the, for example, lead at ICT schools? This is a program that I've researched and studied, that I was part of when I was still in Singapore. It's ICT innovation in schools. I'm looking at the impact of lead at ICT schools project to student achievement, right? Now, if the manipulation can be done randomly, yes, then we're looking at a true experiment. And here I look at, the question can be even refined to say, comparing student outcomes in one lead at ICT school, applying classical pretest and post-test design on a random selection of students. So in this particular study here, I can manipulate the independent variable. In other words, I can use it as an intervention, okay? Because in most cases, you cannot actually do an intervention on individuals, on people. You might breach ethics issues, but in this case we could, right? Because we had all the approvals from the schools and from the Ministry of Education in the Singapore context. Not only can we manipulate the independent variable, we can also do the manipulation randomly. In other words, in one particular lead at ICT school, we could actually subject randomly students in that particular school. Some of them could be exposed to the intervention and some do not need to be exposed to the intervention. So I have an experimental and I have a control group. And I do a pre-test before the intervention. I expose the experimental and the control group. Experimental means those who actually experience the intervention. Control group, they just do the normal way of doing things without any exposure to the intervention. And then I do a pre-test before exposure and I do a post-test before exposure. And in this way, I do a true experiment. I actually want to find out, I try to determine whether ICT innovation impacts student achievement. So this is an example of manipulating independent variable. That means you can actually use it as an intervention. And then when you manipulate it, you can do it randomly. You could actually select students who may be subjected to the intervention and also select those who cannot be subjected to the intervention. Again, if you can't do that, if the manipulation cannot be done randomly, which is most of the cases, because you're looking at schools, there will be ethical considerations that may occur. Why are some students exposed to the intervention? Why are others not exposed to it? So these are a lot of issues. So what usually happens is that if the manipulation cannot be done randomly, what can be done instead is that the independent variable can be randomly measured. And in this case, we're looking at quasi-experimental designs. Again, the very fundamental difference between true experiment is that you can manipulate independent variable, plus you can manipulate this in a random fashion. You could choose who can be exposed to the intervention and those who do not need to be exposed. If you cannot do that, if you cannot do the manipulation randomly, then you're looking at quasi-experimental designs. So here I have non-equivalent control group design with pre and post test. So what I do is I match lead at ICT schools with similar schools, in other words, size, school population, student population. But these students in the non-lead at ICT schools, of course, were not exposed to the intervention. This is the best that you can do. One lead at ICT school where everyone or a significant number of people have been exposed to the intervention, and then a school not having to do anything with lead at ICT, but they're very similar to the school that you're studying. So this is non-equivalent control group because you have a control group and you have quote unquote an experimental group, just that one lead at ICT school, right? And you can do a pre-test and a post-test. This is quasi-experimental design because you cannot randomly manipulate who receives intervention and who doesn't. So this is experimental study. For non-experimental studies, that's when at the very beginning you cannot manipulate the independent variable. You cannot do any intervention, which is majority of the research in the social sciences in education are non-experimental studies because you cannot do intervention. It's expensive. There are ethical issues that may be breached. And in this manner, what you can do is you can compare student achievement between selected schools, lead at ICT schools, and non-lead at ICT schools. For example, you can do something like this, right? And this is a non-experimental study. So what you have here is there's no intervention, right? You're just looking at student achievement between schools that are part of the lead at ICT and schools that are not part of the lead at ICT. This is different from a quasi-experimental design because in a quasi-experimental design, the lead at ICT school still does intervention, but you compare that with a very similar school that has no intervention whatsoever. In this non-experimental study approach, right, there is no intervention to speak of. You're just taking a look at student achievement results of one school and the other. And usually this happens after a certain period of time, after the implementation, for example, of lead at ICT schools. If you're able to measure before and after, then you can actually move it into a quasi-experimental design. But if you can't, if the independent variable cannot be manipulated, you're looking at non-experimental studies. Now, is the independent variable continuous? We have spoken about continuous variables in the last session, in the previous session. So if it's continuous, you're looking at correlational designs. So is there a relationship between the funding of lead at ICT schools, the amount of dollars, and PSLE corresponds to the primary school leaving examination. These are high-stakes tests, and these are continuous variables, range from 0 all the way to 250 to 280, right? So you're comparing whether there's a relationship with the dollar amounts with the results of the PSLE. So these two variables, funding and PSLE scores, are continuous variables. In that sense, you do a correlational design. If the independent variable is categorical, which means it could be nominal or ordinal, then you do a causal comparative design. So what you do is there a relationship between lead at ICT school membership? So lead at ICT school membership is a nominal variable. Is school A a lead at ICT school? Yes or no? Yes. Is school B a lead at ICT school? No. So this is a nominal variable, right? And then you compare it with PSLE aggregate T-score. So the PSLE, which is a continuum of scores from 0 to way above 280, 300, you could actually convert this into interval variables by saying that 0 to 50 would be the first interval, and then 51 to 100 will be the second interval, 101 to 150 will be the third interval, and so on. So here you're comparing categorical variables, a nominal variable, membership to lead at ICT or non-membership, and also the PSLE aggregate T-scores. They have been, the continuous variable has been chopped up to represent specific categories. Right, so we need to just quickly review this and then move on to to the conduct of simple to complex designs. Experimental studies are the they occupy the prime position in quantitative research, but they're really not that realistic to do because it's expensive and there are so many ethics issues that you have to overcome. So most research that you find would be correlational designs, right? Or causal comparative designs even. But most of them would be non-experimental and most of the time correlational. So I'm going to give an example of a research that I'm undertaking. So the particular area that I'm going to look at is what is referred to as hardware. And this is in a Singapore context where I had worked for about close to 7 years. And I'm looking at what they refer to as the Singaporean hardware, engendering a sense of nationhood among the young people in Singapore. Right? And of course, there are several policy settings. So in that tiny nation, they have created several educational policies that have been targeted to nurture, to develop hardware. Right? So they have what is called Thinking Schools Learning Nation, Social and Emotional Learning, National Education. They have Civics and Moral Education. They have the Mother Tongue Language Policy, and they have National Heritage Week. The issue is that Singapore is finding a phenomenon where its people are actually emigrating, not immigrating, but emigrating. They're leaving the country and they're choosing to go to Australia, Canada, to the United States. They're leaving not because of poverty, which is what happens to some countries. They're leaving because they want to find work. But in Singapore, it's one of the nations that has one of the highest per capita incomes in the world. And so people who are leaving, these are affluent people, but they're leaving for various reasons. And so the Singaporean government says, we need to start young, we need to engender a sense of hardware, a love for nation, so that they stay. So this is a very important policy issue in their context because their population is the lifeblood of the nation, and they don't want their locals to be leaving their shores for other places. And in this particular analysis, the team that undertook this research, this was incidentally done at the National Institute of Education's Center for Research and Pedagogy and Practice. We created something like an abstract way of looking at things. We looked at the notion of civic capitals, right? Right here, civic capitals. And then we theorized that civic capitals is made up of civic beliefs, civic dispositions, and civic agency. Beliefs are how young people conceive good citizenship and how young people construct notions of political society. Dispositions are the sense of civic agency and membership. And agency is action, participation in civic activities, and participation that results to political interest. So beliefs is knowledge, dispositions are feelings, aspirations, and agency would essentially be action. So we theorize that all these three comprise what we refer to as a construct, an abstract concept that we talked about in previous sessions, the construct of civic capital. Now let's take a look at some of the ideas that we have analyzed. So in the top right corner, we have this idea of conceptions of good citizenship. And it says there are 8 items. So we used a scale, we created a scale which we referred to as conceptions of good citizenship. And this scale is composed of 8 items. So the first question is, a good citizen is someone who, and then we have 8 items. And the first 3 are indicated here. Respects the rights of others, puts national interests above his or her own, tries to change unfair laws, and down to the other 5 items. So when we take a look at construction of political society, which is the top right box there are 7 items. So the question is, in the near future, how good or bad do you think it would be if there were, and then we have, I have listed down three examples of the seven items, three of the seven. More rights for individuals to do things they want, more rights for women, give your detailed feedback. So these are examples of the scale. So we have here on the lower left-hand corner, sense of civic agency and membership, and then on the lower right-hand corner, participation in civic activities. If you notice, the items are identified, and right next to it is a Greek sign. That's actually Cronbach alpha. And for the top left corner, the Cronbach alpha is 0.88. For construction of political society, the Cronbach alpha is 0.83. For sense of civic agency and membership, the Cronbach alpha is 0.90. And for participation in civic activities, the Cronbach alpha is 0.66. Cronbach alpha is a measure of the internal consistency of a scale. This is a measure of reliability that I alluded to in a previous session, right? So the rule of thumb is that the Cronbach alphas should be above zero point 0.7, right? So most of the scales that I show you here are above zero point 0.7, except for participation in civic activities, which is 0.66, very close to 0.7. Now, the justification that we make here is that we had a very huge sample. We actually did have a huge sample. We had 30,000 students who participated in this particular research project. So with that, we sort of justify saying that with the large sample size, even with a slightly lower than ideal Cronbach alpha, we still contend that this scale is reliable. These are other examples. The research that we did was a longitudinal panel study. Longitudinal means it's not just a one-time study. We did it in three waves, phase 1, phase 2, and phase 3. And in phase 2, we added more scales. Trust in institutions, 8 items, Cronbach alpha is 0.91. Student voice, 5 items, Cronbach alpha is 0.90. Commitment to civic agency, 4 items, Cronbach alpha is 0.88. School as a civic community, 8 items, Cronbach alpha is 0.92. Right? So these are what we used in our analysis. But when we were looking at the idea of civic capitals, we discovered that there were different stories about civic capitals. Scholars, people who have written about it, say one particular story, and their story is basically that the construct that we're using. Civic capitals are a combination of civic beliefs. I think that I have a modest spirit of love for country, for example. Civic knowledge, I know that volunteerism among young people is good, is ideal. Civic agency, I do volunteer work every week at the local community center. And this idea is supported by these scholars in my area, like political science, Verba, Schlossman, and Brady, and also Putnam, right? And basically what they're saying is that increased civic capitals in schools actually equate to good student outcomes. Students who are civically active are usually turn out to be good students. That's what the scholars say when you talk about the story of civic capitals. To be more specific, education enhances participation more or less directly by developing skills that are relevant to politics. Education also affects participation by imparting information about government and politics and by encouraging attitudes such as sense of civic responsibility or political efficacy that predispose an individual to political involvement. So based on this, they say that greater levels of education translate to a higher sense of civic responsibility or political efficacy. That's why a lot of nations are investing heavily in education. Singapore is not excluded from this list. Knowing that this is what the theory says, then let's invest in more education so that our students engender or are foster within among themselves a greater sense of civic commitment to the nation. Studies have been made about linkages between education and citizenship and civic participation. The works of Patricia White, again, the works of Robert Putnam, and even Pierre Bourdieu, when he talks about the new capital, have mentioned about the inextricable link between education and citizenship and civic participation. So this is this one story told to us by scholars. What about institutions? What do institutions say about civic capitals? Well, this is a screen grab from the Ministry of Education in Singapore. And here they say that The Community Involvement Program, or CIP, nurtures our students to become socially responsible and develops their sense of belonging and commitment to our country. Through participating in community work, students also learn the value of service and develop lasting friendships with one another. So the ministry, the institution, says that the Community Involvement Program, which is essentially civic agency, acting out, putting your civic commitment into action, develops sense of belonging and commitment to the country. So in the school system in the Ministry of Education, CIPs are an integral part of the curriculum. Pre-service teachers do it, and students in primary schools and secondary schools, even in universities, do it. I took part in training students in various locations. I mean, in primary school, secondary school, and in the university, in trying to take a look at CIP and service learning. So this is a story told by the institution. So we've heard the story of the scholars who say that education promotes civic participation. The institution says that civic participation, civic commitment, civic agency nurtures love of country. But what about the students themselves? What do they say? So let's take a look at the third story. What do students say? This is one of the questions that we ask students. Singapore is a lot to be proud of. Ordinary citizens can make an impact on how the country is run. Unfortunately, it can't be seen in this slide. I have a strong sense of belonging in Singapore. I want to play an active role in my community. I think I can help improve Singapore society. I feel like a valued person in Singapore. And we ask the students to rank one from lowest to 6, the highest, right? So if you take a look at this, based on what the scholars say and based on what the institution says, we may have some initial guesses on how students rate this particular item, this particular scale. Right? Let's take a look at what they actually said. So, so in this particular table, it says that Singapore has a lot to be proud of, has the highest score. This is for Sec 1 students. And then the lowest score here, Sec 1, and unfortunately it is not indicated, the text can't be seen. Essentially, this one says that I feel like a valued person in Singapore. So Singapore has a lot to be proud of, but the students, the individual students who responded to this, say that they feel like they are not really that valued in Singapore compared to the other items in the scale. So that provokes us to take a look at why does this happen? Why is it that when we talk about sense of civic agency and membership, students score the idea that they feel like a valued person as the lowest compared to 5 other items? And we look at another theoretical argument, this time proposed by Christine Han. And her idea is that, and I will read it here. So, however, another reason might have to be found for the differences in the treatment of students from what is referred to as institutes of technical education, polytechnics, junior colleges, and universities. It seems to be assumed that students of different academic abilities will perform different social and political roles in society. This would explain the recommendation that they are to be regarded differently where national education is concerned. Among other things, there appears to be a policy to encourage a relatively small elite, comprising the academically most able, to think independently about national issues and to arrive at their own conclusions about these issues. So Christine Han talks about differential treatment of students. In the Singapore context, I think in other slides I've mentioned it, in other sessions I've mentioned it. What happens is that the nation's education system, particularly in basic education, primary and secondary, is streamed. So you have what they refer to as low ability students, medium ability students, and high ability students. So everyone is streamed into these various categories. Christine Han is saying that this differential treatment of students could be one of the reasons why when you take a look at, for example, national education, which is a key component of civic mindedness, civic beliefs, and civic action, performs in a very different and counterintuitive way. So we wanted to explore this. Right? So this is the background of our study. It's called the Life Pathway Study, Panel 6. As I said, it's a 4-year longitudinal study. We had three cohorts. We looked at post-secondary students, those in university, junior colleges, and institutes of technical education, those in secondary school, that's S1, and those in primary school, primary 4. And we had a total of 30,000 students. So phase 2 and 3, we had secondary 2 students and primary 5 students. Phase 3 would be secondary 3 students and primary 6 students. And post-secondary levels of PS2, post-secondary second year, and post-secondary third year, either be in the junior colleges, in the vocational schools, or in the institutes of technical education. You may want to take a look at this article that I've written together with my co-researchers, Dr. Tribuna Kang and Dr. David Hogan, and it's found in the PLS Working Papers series. It's Construction of Political Society and Political Interest in Secondary Students in Singapore. So if you want to have more information about it. We had 3 research questions. What is the impact of citizenship education policy, particularly components that have to do with political socialization? Are there differences in the impact among Singapore school children according to their different backgrounds? Let's say gender, ethnicity, streams. SES refers to socioeconomic standing. Are there interaction effects? What conditions heighten or dampen the impact of citizenship education policy among Singaporean students according to their different backgrounds? Right? So these are the research questions that we looked at. So I'm showing you here the results of this idea of constructions of political society, CPS, year 3. Right? So this is a way of representing your data from very bad, how the students responded to it, all the way to very good. So you can actually represent your data in terms of a table such as this. Right? You can also represent it in descriptive statistics, right? Where you have N. Take a look at the second column. N refers to the population. 3,070 responded to this particular question on political society. And if you take a look at each item, let's say more avenues to give feedback of government policies, the mean response was 4.55. Standard deviation was 1.01. We also included the skewness and kurtosis indicators, right? For purposes of this session, just focus on the mean scores, right? So what you see here is that the lowest score is given to this idea of greater restrictions on the powers of government, right? So you can also represent descriptive statistics. Descriptive statistics can actually even be portrayed as a bar graph. And when you take a look at the bar graph, sometimes it's even more interesting or more appealing because you don't see a lot of numbers, but you actually see figures, and the figures show at a glance which ones have the highest scores and which ones have the lowest. Here, greater restrictions on the powers of government is the one that has the lowest score, and more avenues to give feedback on government policies is the one that has the highest scores. It's actually the same table earlier, but represented this time by using a bar graph. And then if you take a look at that particular question and we control it for male or female, we see a difference here. The male mean scores are 4.20 around that area, while the females have scored it 4.30. So it seems here that when we ask the question among our 3,000 or so students, the question about the construction of political society, it seems that the females score higher, as you can see in this graph, compared to the men. But the question is, are these differences actually real, right? Let's take a look at it again. So we have gender, male, a total of 1,445 of the respondents were males, and 1,453 were females. You can see that in the table above. And then you can see the mean scores. You see here that the females scored higher, 4.29, compared to the males who scored 4.20, right? The question is, there seems to be a difference here, but is this difference real? This is when we do simple designs, right? This is the simple design. This is the exercise that we do, right? Once we run a statistical analysis, you will see this in journal articles or in conference proceedings. This is the way to interpret this particular table. So There is a hypothesis that is being stated here, and the hypothesis is that the null hypothesis. Again, in a previous session, you should have already heard about this. The null hypothesis is that there's no difference between the mean scores of the females and the mean scores of the males. That's represented by H not O in the formula right there. The alternative hypothesis is that this is not HO, right? The hypothesis asks if the mean score registered in the construction of political society scale is different for males and the females. We know that the scores are different, right? But is this score statistically significantly different? That's what we refer to in quantitative research as hypothesis testing. So when we do the test, we see that there's a main effect of gender, right? So we see that the degrees of freedom, which is 1, the degrees of freedom as represented in the table above, and then 2897, right, refers to the number of respondents, the capital N, and then we have 10.430. This is the F value in the corrected model. You can see it on top. The mean square error is 6.314. You can also see it on the top right there. And the significance value is 0.004. And the alpha is 0.05. Our alpha was 0.05. There is sufficient evidence to conclude that the males and females, the mean scores are probably different. So here, we basically reject the null hypothesis that there are no differences between the mean scores of men and women, or males and females. The mean scores that we saw earlier in the table were actually really different, right? And so when we take a look at construction of political society in a Singapore context, we can safely say that boys, males, and females score the construction of political society scale in different ways. Right? That's an example of a simple design using gender as a control factor. Now, what if we use ethnicity? In Singapore, there are actually four main races: the Chinese, Malay, Indians, and others. Right. So now here we take a look at the same question, but this time we're not controlling for gender, but we're controlling for the ethnicity of the respondents. So the table above tells us that 2,214 of the respondents were ethnic Chinese, 404 were ethnic Malay, 162 were ethnic Indian, and the rest, 70, were others. These are foreigners who are already, these are students who are not Chinese, Malay, Indians, probably from other countries who have already migrated to Singapore. Mind you, these representations are actually a proportion of the population in Singapore. Majority Chinese, and then Malays, Indians, and others. So the sample size that you see here is a representation of the entire nation of Singapore. Now, if you take a look at the second table, you quickly see that there are differences in the scores, the mean scores, and how they measure construction of political society. The ones who scored highest are the Indian students, Indian ethnic students. The ones who scored the lowest are the others, right, in terms of construction of political society. The ones who scored next highest were the Malays, and the Chinese ethnic students scored the third lowest, right? So when you see descriptive statistics such as these, it's not good practice to quickly say, hey, so they're very different from one another when we control for ethnic background. We need to do statistical tests. We need to do simple tests of design, simple tests to essentially find out whether there's a statistically significant difference in the scores that are registered. So if you take a look at it, again, that table represented in this graphic form shows the huge variation in scores. Indian ethnic students scored the highest, and others scored the lowest. Simple design again. So this is the table that we see. The hypothesis that is inherent in this table basically tells us that there's no difference. The H naught, the null hypothesis, says that there is no difference between the mean scores of Chinese, Malays, Indians, and others. The alternative hypothesis is that no, there are differences. We need to remember that in quantitative research, it operates in a bit of a counterintuitive fashion. In order for us to prove a result, that there are differences in our analysis, we need to initially state that, hey, there are no differences. That's a null hypothesis. And then when we gather the data, if we're able to reject the null hypothesis that there is no difference, then we can say that there is a difference. If we fail to reject the null hypothesis, then the null hypothesis stays. In other words, the imagined or the expected differences that we hope to see, they don't exist. Okay. We saw that the scores were different, but are these statistically significantly different from one another? So we do this analysis of variance. The hypothesis asks if the mean score registered in the CPS scale, Construction of Political Society, is different among the 4 different ethnic groups. Let me repeat. The mean scores were different, but were these mean scores statistically significantly different? You see, they could be different, but if they're not statistically significantly different, then that means that the difference is due to chance. But for statistics, we want to be very sure. We want to make sure that the differences are robust and not merely due to chance, right? What did the results say? Between subjects analysis of variance reveals no main effect of ethnicity, right? The degrees of freedom is 3, as you can see in the corrected model on top. 2849 refers to the total number of respondents. 2.112 is the F score. Mean square error is 1.284. And you can see the p-value is 0.097. And then our alpha is 0.05. In other words, if it's lower than 0.05, it's statistically significant. But if it's higher than 0.05, which is what our p-value is, 0.097, then it is not statistically significant. There is insufficient evidence to conclude that the ethnic mean scores are different. The different scores that we see cannot be supported by statistical results. These differences could be due to chance, right? So we cannot move further along. So we need to say that, well, when we take a look at gender in terms of construction of political society scale in the Singapore context, it is a meaningful variable. There are differences between men and women there are differences in looking at the construction of political society scale by using gender as a control factor. It's meaningful. But when we use ethnic differences, when we look at construction of political society scale, it's not too meaningful because the differences are not statistically significant. Now, what if we use streams? As mentioned earlier, in Singapore, they stream the students into, in secondary school, they call it normal technical, that's the lowest level, then followed by the normal academic, followed by express, followed by special, followed by those in the integrated programs. This, again, mind you, were the streams in 2007. They have since then modified them, right? So anyway, those are the streams. So now we're controlling for streams, and if we can see, the mean scores are apparently different. Those in the integrated program, supposedly the smartest, high-performing students score the highest. Those in the special stream score the second highest, followed by express, followed by normal academic, followed by normal technical, right? But again, caution, are these differences real? We need to do statistical tests. We need to do a simple test, right? Representing those figures in this graphic, we can see that the IP students, integrated programs, score the highest, normal technical score the lowest. Again, it's another way of depicting the numbers in a more appealing, perhaps a more visually stimulating manner. We still continue with a simple design. So we take a look at the hypothesis, essentially, the null hypothesis that there's no difference between the mean scores if we control for the academic streams. That's represented by the H not O, mean is equal to mean IP is equal to mean special, equal to mean express, equal to mean NA, normal academic, equal to mean normal technical. There's no difference. Alternative hypothesis, H not 1, not HO. The hypothesis asks if the mean scores registered in the CPS scale is different among the 5 different streams. Can you tell what the result of the test of hypothesis is, since we've already done 2 iterations previously? Are the differences statistically significant? Could we reject the null hypothesis, which means that we acknowledge that there are differences, or do we fail to reject the null hypothesis, which essentially means that if we take a look at construction of political society scale, controlling for academic streams is meaningless. What do you think? Okay, let's look at the results of the test. The between subjects analysis of variance reveals a main effect of stream. Again, the degrees of freedom is 4. The total number of respondents is 3023. The F value is 14.56. The mean square error is 8.661. The P value, this is the column which is the second to the last column, sig, it says, is 0.00. It is below the alpha of 0.05. There is sufficient evidence to conclude that the stream mean scores are probably different. So when we take a look at construction of political society scale in a Singapore context, using academic streams as a controlling variable is a meaningful way to move forward because we see differences in the scores based on the survey that we did. Right? If we continue by using socioeconomic status, what we've done in our research is that we could not get students to identify what their socioeconomic status is because it may be highly unreliable. So we used their reported dwelling as a proxy, as a substitute that represents their socioeconomic standing. So we have rented 1 or 2 room housing development board flat. A housing development board is usually public housing. So rented 1 or 2 room HDB flat, a rented 3 room flat, more expensive than the 1 or 2 room, a rented 4 room flat, of course more expensive, 5 room flat, even more expensive. It could be a private condominium, which is no longer public housing, which is not part of the housing development board, or it could be landed property. So this time around, we are controlling for what the students reported to as their dwelling place. And in this sense, we are trying to see whether, if we take a look at SES, will there be any differences? The second table, the descriptive statistics, tell us that the scores are different. We see variation. Those who are in the landed property score the highest. Those who live in HDB 3-room flats score the lowest. If you take a look at this other slide, it gives us a clearer picture of the variation among the different types of dwelling units by the students and their responses to the question related to construction of political society. Landed property, these are the ones who have land and house. We must remember that Singapore is only 600 square meters. That's the entire size of the nation. So land is a premium. It's very expensive to get land. And if you have land, that means that you are an affluent, you belong to an affluent family. Most of the people live in housing development board flats, public flats, and then there are some who also live in private condominiums, right? Simple design. This is still simple design, right? But now we're controlling for the socioeconomic standing. Null hypothesis is that there's no difference between the mean scores according to their reported dwelling place. The hypothesis asks if the mean scores registered in the CPS scale is different among the 6 different residential types. So I ask you, since this is already the 4th exercise, do you think that the differences are real? Is it meaningful to talk about construction of political society, controlling for socioeconomic standing? Well, again, the between subjects analysis of variance reveals a main effect of residential types. The F value is 2.777. Degrees of freedom is 5. The total respondents was 2784. The mean square error is 1.603. The p-value is 0.017, which is below the alpha of 0.05. There is sufficient evidence to conclude that the mean scores, according to residential types, are probably different. This notation that I've been providing to you in these 4 exercises is the American Psychological Association convention of writing statistical results. So when you write your research report, you need to follow this particular convention. You need to report the F value, you need to report the mean square error value, you need to report the p-value, and you need to report the degrees of freedom and the total number of respondents in the survey. This is a correlation table. In here you can see that these are the different scales that we have used. Construction of political society scale, the one that we've been using, sense of civic agency, political interest, good conceptions of good citizenship. These are all in the column, and in the rows is the same items, but now we're doing a correlation, inter-item correlation, how they're correlated with themselves. If you see in the diagonal, there's a 1 in the diagonal. So construction of political society correlated to construction of political society is 1. Sense of civic agency correlated to sense of civic agency is also 1. So if you trace the diagonal, you see 1, 1, 1 all throughout. This is an excerpt from a huge correlation table. This tells us that this is an example of a correlation table, a table of correlations. It's very helpful to do this because when you see correlation tables, and when you take a look at the results, that's where you actually can, when you see that there's a high correlation, and high correlations, usually the rule of thumb here is that if they're higher than 0.3, right, if the scores that you get are higher than 0.3, then statisticians and quantitative researchers say that something is going on between the two variables, and therefore it warrants more detailed research, right? So a correlation table tells us that some of the items here are pretty interesting to look at, right? So now I'm going to move on to a complex design, because now we're going to take a look at two different levels. We're going to take a look at gender, and we're going to take a look at streams. If you remember, in our exercises previously, we discovered that gender is a meaningful variable to use, because when we looked at gender alone and looking at construction of political society, there were statistically significant differences. And then when we looked at stream, we also saw that there were statistically significant differences. We're now going to go to a complex design where we put together gender and stream, and we're trying to look for an interaction effect. In other words, what factors, how do different variables interact with each other in terms of the dependent variable? And here what we're testing is gender and the stream that these students, male and female, belong to. So this table, the table above, shows as the respondents 1445, 1453 for males and females respectively. And then according to streams, you see 109 belong to the integrated program, the highest stream, and 280 belong to the normal technical stream, the lowest program in terms of academic ability. And the lower table shows us the descriptive statistics. You see there's variety in scores. Okay, males from the special stream scored the highest, 4.452. Females from the integrated program scored the highest, 4.4. But again, we ask ourselves, are these differences meaningful? Are these differences statistically significant? Now we go into complex designs, right? So this is another way of looking at the table, but using colored lines to make it more visually interesting. So you have male, female, and you have the colored lines representing the streams. And you can see how the females score the males in almost all respects except for the normal technical, the yellow line where you see that the females score lower compared to their male counterparts. Now, we're looking at a complex design. So let's take a look at the null hypothesis. The null hypothesis says that male, female IP, male special, female special, male express, female express, all the mean scores of these various combinations, there are no differences with each other. That's represented in the null hypothesis, the H naught. And of course, the alternative hypothesis is that, no, there are differences, right? You've done this in 4 exercises previously. We're now in group exercise 5. What do you think will be the result of the test of hypothesis by looking at the table alone? The hypothesis asks if students' CPS scale scores is the same for gender and streaming conditions. Right? The between subjects analysis of variance reveals an interaction effect. There is an interaction effect of gender and streams. So what we're going to look at now would be that row which says gender times streams. Gender is represented as gen underscore S3. Streams is represented by STRSS underscore S3. So that particular row, that row reveals to us that that the F value is 4.760. The degrees of freedom is 3. Total number of respondents is 2897. Mean square error is 2.819. It is statistically significant. That is, there is sufficient evidence to conclude that the CPS scores is probably different for gender and streaming conditions, right? So here we see that there is an interaction effect. But when we take a look at gender, above here, we see that the p-value is 0.378. It is no longer statistically significant, whereas streams is still statistically significant. The p-value represented by sig is 0.000, right? So here is as an example of a complex design. Here, when we combine two variables, we are able to get an interaction effect, right? And this is helpful for us to consider. So we can now see that gender may not be a complete way of looking at differences, because when we add streams, we really see where the differences are, right? Gender plus streams provides us an interaction effect. It provides us a clearer picture of the complexity of how young people in the Singapore context interpret and see the phenomenon of construction of political society. Usually what you do, once you see that there is a significant difference, you do what is called the post hoc tests, tests after the fact, right? And this is an example of the post hoc test, because what the previous test proved to us is that there are differences. That test is called an omnibus test, a total test, but that is followed by a post hoc test. And this is an example of the post hoc test. This is still a continuation of the previous analysis of the complex design. Where do the differences occur? Does it occur in the integrated program, in the special stream? Well, our post hoc tests tell us that the differences actually occur in the express, that's where you find the highlighted scores, and in the normal academic streams. This is where the differences actually occur, right? So the omnibus test tells us that there's an interaction effect between gender and streams, but it does not tell us, the omnibus test doesn't tell us where exactly does this occur. We do the post hoc test, the tests after the fact. That's what it means, post hoc, POST-HOC, after the fact. And the post hoc test here, this is a Bonferroni post hoc test, tells us that the differences are in the express stream and the normal academic stream. And then we can actually even see the magnitude of the differences. You find here the mean difference, the I minus J. These are the scores, how the scores differ between the express students and the normal academic students. So we have just completed several exercises moving from simple research designs, correlational research designs and analysis, towards more complex correlational analysis, incorporating multiple variables analysis. It's good for us to go back to the research questions that triggered these analyses. The first question was, how do students rate themselves in terms of the constructions of political society? From the findings, it would seem that the differential treatment of students, as indicated by Han in 2000, impacts the notion of construction of political society. This is evidenced by statistically significant differences of students' responses, controlling for educational stream in schools. Now, policy implications of these are that the Singapore government may want to reconsider whether they'd like to continue this differential treatment, or whether they're happy with it. Do they want students to have similar notions of civic mindedness regardless of what academic stream they are? Or do they want to revamp this and make sure that students share similar egalitarian concepts of civic mindedness regardless of their academic streams? This kind of question is not covered in this study, but it could be worthwhile policy implications that can be explored in future. Second question, how is it different among several fixed factors, gender, ethnicity, streams, and socioeconomic standing? The results of these exercises showed us that ethnicity did not register meaningful, in other words, statistically significant differences. However, gender, streams, and socioeconomic status registered statistically significant differences. Possible policy implications: if the Ministry of Education would like to tweak the curriculum of national education or anything to do with civic education, it may be wise to not look at these curriculum modifications from an ethnic perspective, because the findings did not reveal anything meaningful from that direction. It may be worthwhile to take a look at streams, particularly streams and socioeconomic standing as the levers to manipulate if there are any attempts to modify the curriculum in relation to civic education. Third question, are there interaction effects? There was a statistically significant interaction effect for gender and stream. Initial post-hoc tests using the Bonferroni correction method reveal that these differences can be found in the express and normal academic streams. More analysis of the interrelationship between streams and gender is warranted. Again, possible implications of this would be if the ministry wants to tweak the implementation of civic capitals, how does the current method of streaming students have an impact on that? Because our findings reveal that it does have an impact. So moving forward, the Ministry of Education may consider, okay, with this knowledge, how do we use this in enhancing civic participation, not just among the express and normal academic streams, but maybe for all the other streams. Now, these questions cannot be answered by using this data alone, but these are, again, worthwhile questions to ask when we take a look at the notion of civic capitals. And the data that and the findings that have been generated from this series of exercises form the basis of form a good foundation in asking these policy relevant subsequent questions. That ends our session on correlational designs, associations, and multiple variables analysis, simple to complex designs. If you have any questions or clarifications, don't hesitate to get in touch with me through the email that you can find in this particular slide. Thank you.